from the Gauteng, September 2023. Question 5. The graphs of f at x and g of x are sketched below. The graphs of f and g intersects at points D and B. Points A and B are the x-intercept of f. 5.1. Write down the coordinates of E, the turning point of f. We are given the equation of a parabola in this form, where P is the x-coordinate of the turning point and Q is the y-coordinate of the turning point. The coordinates of E therefore must be 7 over 2 is to 81 over 4. 5.2. Determine the average gradient of the curve between x is equals to 1 and x is equals to 5. F of x is given by negative x minus 7 over 2 squared plus 81 over 4. I am given two x values, and I know that in order to calculate the gradient, I must have a change in y over the change in x. So I need to know what the y values are when x is equals to 1 and when x is equals to 5. I'm just going to substitute when x is equals to 1 into f. This is 1 minus 7 over 2 squared plus 81 over 4. And I'm also going to substitute when x is equals to 5. 5 minus 7 over 2 squared 81 over 4. Negative into 1 minus 7 over 2 squared plus 81 over 4. I am getting a 14. So the coordinates must be 1 is to 14. And then the other one is a 5. And then this is equals to 18. The coordinates are 5 is to 18. Now I can calculate the average gradient. The change in y, that will be 18 minus 14. The change in x, that would be a 5 minus a 1. 18 minus 14, 5 minus 1, that gives me a 1. So the average gradient is equals to 1. 5.3. Calculate the coordinate of A. So they want the value of A, the x-coordinate of point D. At the point of intersection, f of x is equals to g of x. This is minus x minus 7 over 2 squared plus 81 over 4, which is equals to negative 3x plus 24. This is negative into x squared minus, that is going to be 2 times 7 over 2. That is going to be a minus 7x. And that is going to be a plus 49 over 4. Plus 81 over 4, which is equals to minus 3x plus 24. This is a minus x squared plus 7x minus 49 over 4 plus 81 over 4 plus 3x minus 24 is equals to 0. This is minus x squared, that is a 10x minus 49 over 4 plus 81 over 4 minus a 24. Getting a minus 16 is equals to 0. Then I'm just going to divide everything by negative 1. This is minus 10x plus 16. The factors of 16 that will give me a 10 is an 8 and a 2. And they are both negative. X should be equals to 2 or x should be equals to an 8. The value of A should be equals to 2 because this x coordinate there is smaller than that x coordinate there. 5.4. Point S axis to y is a point on the graph of f where x lies between a and 8. Line ST is drawn parallel to the y-axis with point T on the graph of f. Well, A is 2, is to x, so x lies between 2 and 8. ST should be equals to, if I want to find this distance right here, I need to know what the y value there is and then what the y value there. So I'm going to say the y value that is on top minus the y value that is below. This y is represented by minus x minus 7 over 2 squared plus 81 over 4. And then that y there is represented by minus 3x plus 24. So essentially I'm just saying f of x minus g of x. These two at this point were equal, right? And then when I transpose g of x to the left hand side, I'm going to have f at x minus g of x, which is equals to 0. So all of this should be equals to that. So this is minus x squared plus 10x minus 16. So I have expressed st in terms of x. 5.5. Calculate the maximum length of st. St of x is equals to minus x squared plus 10x minus 16. In order to find the maximum length, I need to find the derivative of that. This is minus 2x plus a 10. And then at the maximum point, the gradient should be equals to 0. Minus 2x plus 10 is equals to 0. So x is equals to a 5. And then I'm just going to substitute the 5 there. Squared plus 10 to 5 minus 16. Negative 5 squared plus 10 to 5 minus 16. I am getting a 9. Therefore, ST is equals to 9 units. Question 6. The graph of f at x is given by, this is 3 to exponent of x, is sketched below. P, that point right there, is a point on f. 6.1. Write down the inverse of f in the form y is equals to. F of x is equals to 3 to exponent of x. This is y is equals to 3 to exponent of x. The first step is to interchange the x and the y. And then now we need to make y the subject of the formula. You will say the exponent is equals to the log of the base multiplied by the answer. The exponent is a y, log of the base is a 3, and the answer is x. 6.2. Sketch the graphs of the inverse and y is equals to the inverse x minus 2 on the same set of x's in your answer book. Clearly indicate all the intercepts with the x's. So your knowledge of inverses needs to be very extensive in order for you to solve this question easily. So the coordinates there will be 0 is to 1, because I'm just going to say y is equal to 3 to exponent of 0, which is going to give me a 1. That would be the y-intercept. Okay, for the inverse, we just interchange the values. So right now you can see that the y-intercept is 0 is to 1. The y-intercept of f will be represented by the x-intercept of the inverse. So the coordinates there for the inverse, they need to be 1 is to 0. So this will be 1 is to 0. And then now we're going to look at point P. So now the coordinates must be 1 over 3 is to negative 1. This is going to be 1 over 3 is to negative 1. So we just swap the coordinates. And then my graph is going to look something like that. And then that is the graph of the inverse. And then now they have that x minus 2. So this is x is equal, okay, that is a fact. So you'll say x minus 2 should be equals to 0. So x is equals to 2. So we need to shift this graph that we have right now 2 units to the right. This is us shifting that graph. So that point will be 3 is to 0. And then we also need to shift the x value 2 units to the right. So 1 over 3 plus 2, that's going to give me a 7 over 3. And the value of y doesn't change because I'm just moving the graph to the right. I'm not moving it up or down. So now the other point will be there. And then, yeah, I'm going to have those two. So this graph is x minus 2. 6.3. Use your graphs drawn in 6.2 to solve for x. The log of 3x minus 2 should be less than a 1. Okay. Log of 3, 5 minus 2. Log of 3, 5 minus 2. This gives me a 1. So I know that the upper value there should be a 5. Now I just need to find the lower value. The lower value is going to be in x is equals to 2. When I say log of 3, and then because you notice how this doesn't cross over to the y-axis. Now imagine that becomes the asymptote of the red graph. So this will be x is equals to 2. So when I plug x is equals to 2, I'm expecting to get an undefined solution. So when I say 2 minus 2, I'm expecting to get an undefined solution because the graph cannot go over its asymptote. Yes, so it's undefined. So this means that the solution should lie between a 5 and a 2.